Alright, so for this video we're going to go through chapter 12 and how to solve all the types of problems that you're going to see in the homework, and more importantly, the ones that you guys have traditionally have trouble with. So we'll just go through this homework assignment. We'll start with number 1. The solution is made by dissolving 26.54 grams of NH4-2SO4, so ammonium sulfate, in enough water to make 49.85 milliliters of solution. Now, something to keep in mind, pretty much anytime you see water, that's going to be your solvent, okay? So your solute is going to be that one, okay? So the equation, right? So molarity equals moles of solvent over liters of my total solution, okay? So the question was, what is the molar mass of NH4-2SO4? Well, I'm going to cheat and say that it's 132.14 grams per mole. So 132.14 all right, and again, really get used to writing your units down so you keep track of what's what. So this is going to give me an answer of moles of NH4SO2. So we've got 26.54 as my starting point. Grams of NH4-2SO4 over 1 times that. So I'm going to take 126.54 grams. I'm going to divide it by 132.14. And I'm going to get the number of moles. Okay? So I have the number of moles of NH4-2. And I left my calculator at home, so we're going to do this the old-fashioned way. So 26.54 grams divided by 132.14 is 0.2008. Give yourself some room, right? Don't just instantly round it off because you're going to need to keep some. So 0.20085. 0.20085. Now what are my units? Well, grams cancels, so moles of NH4-2SO4. All right, so now I have a mole value, which is what I needed right here. So now I need to figure out a liter value. Okay, well, we're looking for our 26.54 grams. We turned that into moles, so that's perfect. And enough H2O to make a 49.85 milliliter solution. All right, so I've got 49.85 milliliters. Okay, but I need it has to be in liters. All right, if it's not in liters, it's not going to work because that's what the equation calls for. So I've got to change this into liters. I'm going to divide by 1,000, okay? And that's going to equal 0.04985 liters. Move the decimal 3 times over. That's my liter value. That's the number that goes here. All right, so now I have units of moles in the liter, which is a concentration. That is a molarity unit. And then when I get done dividing, you're going to get your answer of 4.029. Okay, now the one that always gives everybody the most trouble is number 2. How many milliliters of a 0.750 molar H3PO4 phosphoric acid solution are required to react with 254 milliliters of a 0.142 molar barium hydroxide solution if the products are barium phosphate and water? Okay, well, like we went over today in class, I don't have enough information to solve only one of these because, again, your equation is molarity equals moles over liters. You can rearrange that to solve for any of the 3, but you have to know 2 of the unknowns. So for H3PO4, I know I have molarity, I have liters, and I have moles. And then for BaOH2, I have molarity, liters, and moles. Well, I know I have 0.750 molar solution of phosphoric acid. So a 0.754 molar solution I don't have a liter value given, and I don't have a mole value given. So as of right now, I can't do anything here because I'm missing I need 2 out of the 3. I only have 1. All right, so I go, well, I don't have enough of those. Well, let's try barium phosphate. Let's see if I have enough information to solve that one. Okay, well, that's a 254 milliliter. All right, a 254 milliliter solution. So 254 milliliters, that's 0.254 liters. Let's see what that's supposed to go there. All right, and let's see, do I know? So I know 1, and I know it's a 0.142 molar solution, so that's the concentration. So 0.142 solution. All right, so the only thing I don't know here is the number of moles, okay? Well, that I can do, because I only am missing 1 unknown. So for that equation, I'm going to set it up. I'm going to rearrange this one here for moles. So what I do is I got to multiply. So again, write your original equation. Molarity equals moles over liters times liters over here. So that cancels. Moles equals molarity times liters. Okay. Well, I've got a molarity value, 0.142 times liters, which is 0.254 liters, and this is grams or moles per liter. So I'm going to get an answer in moles. Okay. And handy dandy calculator. Oops, check the ink down. Doesn't like that at all. So So 0.142 times 0.254 liters gives me a mole value of 0.03607. So 0.03607 moles of BaOH2. Okay. So now I know all of these. 0.03607 for there. But now I can do a ratio. Now that I know moles of barium hydroxide, I have a balanced equation. Anytime I have a balanced equation, I can generate a mole ratio, some stoichiometry. I can calculate everything else. So we know it was H3PO4 plus BaOH2. Well, that's going to yield Ba3PO42 plus, I'm running out of room, H2O. Okay. Now we know it's Ba3PO42 because barium here, means this is barium with a 2 plus charge. All right. There's 3 hydrogens here, which means this is phosphate with a, running out of room, -3 charge. So I'm going to have to switch those to get a 3 here and a 2 here. When we balance it, it is 2, 3, 1, 6. So now I have a balanced equation. I already know my moles of barium hydroxide, so I can use that as my starting point. All right, and that number was from back here was 0.03607. 0.03607, use your units, moles of BaOH2. I promise if you set things up in the manner that I show you and use your units, you don't have to memorize anything and you won't confuse yourself. Now, times a mole ratio from where? From this equation. That number and that number. Oops. That's a little weird. So that one and that one. Okay. Now, what goes where? Well, I've got moles, barium hydroxide in the top, so that's got to go in the bottom. All right, and the number associated with it, which was a 3. And the other one goes in the one I'm looking for goes on top. So 2 moles H3PO4. All right. So when I get done, so I'm going to take my 0.3607 moles of my starting point. All right. So 0.03607, and I'm going to times it by 2 and then divide that answer by 3, and I'm going to get 0.02405. So 0.02405, 0.02405 moles of H3PO4, because that's, if I get done canceling, that's what's left. All right, 0.2405, well, 0.02405. Now I know moles. Now I know 2 of my 3 for phosphoric acid here. So I can now solve for liters. All right. So molarity equals moles over liters. So I multiply both sides by liters, and I get liters times molarity equals moles. And I divide both sides by m, and I rewrite my equation. Liters equals moles divided by molarity. All right. Well, I know those numbers. I know my molarity is 0.754. Okay. And I know my moles is 0.02405. All right. Moles over molarity ends up with units in liters. So I do this math. You got lots of numbers, so it's good to keep your units so you know which ones are refer to which. It's also good to keep some sort of logical sequence when you're setting these up so you can go back and look at it and figure out what you did. 0.2405 divided by 0.754 equals 0.03189. Now, that's units in liters. It's asking in this problem for units of milliliters. So I multiply by 1,000. I move my decimal 3 times. 31.9 for 3 significant figures. 31.9 milliliters. Okay. Uh-oh. Oh, that's why. 0.750 molar, is that what number I used? Oh, I put 754. Oops, so this was wrong. That's okay, so now, well, we can identify where we went wrong. I wrote the wrong number down, 0.750 here. Okay, so now we just gotta go back. Well, where did we use that number? Well, we used that number right here. So let's switch it. This is why we write down all of our work. And now we just gotta go, it's easy to fix. All right, so we'll see if that comes out to be the right number. So we're going to clear everything. We left our work up 0.02405, so it's easy to change. Divided by 0.750. All right, and we're going to multiply that by 1,000, and we're going to say 32.1. All right, we're on to 3 significant figures. 32.1 milliliters. All right, that looks a lot better. Now, for this second one, similar, but not as much work. So for number 3, so 75.1 milliliters of a silver nitrate solution reacts with enough copper to produce 0.261 grams of silver by single displacement. So what is the molarity of the initial solution of silver nitrate solution? So what you have to do is you got to turn this into grams right here. So you write and balance your equation. All right, so based on this number right here, this is going to be copper 2 because nitrate has a +1 charge. All right, so that's going to help when you go to balance it. So I'm going to need 2 AGs and 2 AgNO3 and 2 Ag. All right, and then we're going to just turn this into grams by dividing that by the molar mass. Then based on the balanced equation, it is a 1-to-1 ratio of silver to silver nitrate, 2 to 2 technically. So then that's the number of moles of silver nitrate that I calculate. So I just divide 0.261 by the molar mass of silver. Then I'm going to put that, I'm looking for molarity, so it's moles divided by liters, so I just have to convert the 0.751 to liters, so 0.0751, and then use that, divide the number of moles that I get here by this converted to liters, and you're going to get the molarity. Okay. Let's skip down to number 5. How many kilograms of water must be added to 74.2 kilograms of calcium nitrate to form a 0.749 mole solution. Okay? Now, molality, remember, is moles of solute. So molality is moles solute, what you're pouring in, what's being dissolved over moles of your solvent, which is going to be the liquid doing the dissolving. And if water is present, water is going to be your solvent. All right? So we're trying to figure out, in this case, oh, sorry, not moles of solvent, kilograms of solvent. So for this problem here, number 5, we're trying to figure out kilograms of water. Okay, so we've got to rearrange this equation, for our molality equation, for kilograms. So I multiply both sides by kilograms. Okay. Rewrite. So now I have kilograms times molality equals moles, but that's not what I want. I want kilograms. So I'm going to divide both sides by molality. Do to one side, you got to do the other. Rewrite. So kilograms of my solvent is the moles of the solute over the molality of my solution. Okay? So I've got a 74.2 grams. So I've got 74.2 grams of CaNO3 2. And my concentration, the molality, is a 0.497 solution. Okay. So I don't yet. I need to know moles and molality. Well, I know my molality right here. I don't know my moles yet because I've got grams currently. So I have to convert. Right? So first things first, always moles. 74.2 grams of CaNO3 2. And let's see, 1 mole of all of that, I'm running out of room, is how many grams? Well, we have to add this up. So let's figure out the molar mass of calcium nitrate. So there's 6 oxygens. All right? So 6 oxygens is 16 times 6. So O, 16 times 6, that's 96. N, there's 2, 14.01 times 2, 28.01, and then 1 calcium, whatever that happens to be. So let's add it all up. All right. So calcium is 40.08. All right, so 40.08. So 09, and then I've got a 4, carry the 2. I've got 48, so 174.09. That's what it looks like. So I'm going to divide this by 174.09. And so 74.2 divided by 174.09. Let me make sure my math is right. Actually, just because it's been a long day. 96 plus 28.02 for one thing. There's one mistake. Plus 40.08. 164.1. That'll do it. All right, so but we left all our work up there, so it's really easy to fix. We just say 74.2 divided by 164.1, and I get 0.45216 moles. 0.45216 moles. Okay. Now, I finally now know the missing mole piece to finish this equation. Let's see, about out of room. Oops. Let's undo the deletion of that page because I'd like to keep it. There we go. So I know moles, 0.45216, 0.45216 moles. And we know our concentration. Our molality was 0.497 given in the equation. And then we're just going to do that math. So 0.45216 divided by 0.497 equals 0.9098, 0.9098 kilograms, or with three significant figures, 0.910 kilograms, 910 grams. Let's see what they wanted the answer in. So they wanted an answer in kilograms, so we got our answer 0.910 kilograms. So this is the way to do pretty much any molarity-molality equation, even sort of the really complicated ones. Again, the only thing you can do is show all of your work. That way, if you do make a mistake, kind of like we did here with the wrong molarity value, well, then it's really easy to go back in and fix, because even if you calculate the wrong number, you know where your steps are, you know where your work is, everything's sort of logically laid out and identified with units, and you can just easily go back in and fix everything.